We are recording. Okay. So here's my first question. Here's my first question about this. As far as I remember, we decided that we're gonna do this in the preprocessor, right?
Right.
That's what we decided. We should rename things in the preprocessor. However, name collision is a thing. Name collision is a thing.
Um,
So I think we should, yeah, here. Collect all variables, iterate over args list, replace non-variable args with generated variables, and add the notification explicitly to the beginning of the body. So this is like we are introducing new code, not in the Erlang level, but in the Karuta actually. This is adding to our AST.
yes. Actually, I just had an idea, and it may be a stupid idea, but it's an idea nonetheless. What if we get around that by using just numbers as the new variable names that we're introducing?
You are proposing that because we don't allow people to put variable names as numbers.
Yeah, because a variable must start with an uppercase letter, right? Or I guess we can allow underscores as well, but that's neither here nor there. The point is, if you just have a number, that parses as a number literal, not actually a variable, right?
Yeah, we can use numbers because we are already inside the matrix, right?
Yes, because we can, since we're generating Erlang ASTs directly, we can actually, I think we should be able to bypass that requirement because at the AST level, a variable is a tuple with the symbol var at the head and then the variable name as another atom, but the atom can be quoted, you see, so we can put a quoted number, like a numeral, and an atom which is just digits in there if we want.
Wait, you are saying to do something like this? Sorry, this?
Um, Not quite, because like if you just do this, that in the AST level, that becomes a constant, which is an atom, which has
Exactly.
0 as the
Yeah,
name,
but
right?
if you're proposing to use numbers, but how can we use numbers on the level of the Erlang level?
Because we're not emitting Erlang, we're emitting Erlang AST, we're one step removed from the surface syntax.
Yeah, I understand, but how does that give us the capability of using numbers in this case?
Because at the AST level, there's a
Ah,
different.
in the abstract format, you can just put a var in the tuple.
You can just say, okay, this
Man,
node is a var, and the
does
name
that
is.
work? Are
I
you
don't see
sure?
why it shouldn't. I don't see why it shouldn't.
We should verify that before committing to the idea, in my opinion. Margareta, did you understand how wait, I should say dumb and genius at the same time? What
I
Marin
was
just
thinking
said.
actually by something else, but what is that?
Okay, so we are discussing about argument renaming. Okay, and why is that? Because we need to undo the names that you provided in Karuta. So in Karuta, this would be plus out 0 out. Okay, and then blah blah blah. Do you understand that this is not doable in Erlang, right?
Yeah.
Okay. Then we need to, well, the original idea was, okay, what about just renaming them? And if you're doing pattern match, such as the argument 1 in this case, you need to do that explicitly with the equals. Um, yeah.
Okay.
Well, this is not this, by the way. I'm just giving it
No,
a
no,
stupid example.
yeah.
I think this would be more this probably. Here's the problem. Well, what is the naive solution? Go to your preprocessor and rename these things and introduce equals yourself. When I say yourself, I mean the compiler. The compiler introduce new things for the pattern matching that you did on the head of the declaration. Well, this head of the
Mhm.
declaration. Okay, so far?
Yep.
What Marinho suggested which is like again dumb and genius at the same time. What about we instead of using these names, we just use numbers because we don't allow you to make numbers variable names in Karuta. If you put a number, that is considered a literal, not a name.
Yeah.
So, but then the situation is, how can we use a number in Erlang? And then Marinho corrected me. We are not using Erlang. We are using abstract format, which as far as we know, to make a variable is just, why wouldn't this be a variable?
Yeah, you have to single quote the 0, but it should work, yes,
Like this.
basically.
And then my
I don't see
question
why
is,
that is
does this
dumb
work?
and genius.
I don't see why it shouldn't.
I don't think there's a space that you need to declare names, right? They're completely opaque at this point.
Yeah, but do they allow you to declare on the level of the AST a variable with like a
Well, try
literal?
parsing it because I think that would just be an atom, right? So I think yeah,
Are you guys
it's hard.
turning into an Erlang file at any point? The answer is no.
I have one problem though.
Sure.
Uh, what if we import a library? Because in Karuta, sure, you don't allow that. But what if like some library does?
Does what?
Doesn't
Like,
matter because these are just names for function arguments. We are that we are emitting ourselves. It doesn't matter if the names are used in a different way outside of those functions.
it's all isolated on scope, right? So I think yeah, it's
Yeah.
probably fine.
Well, you said you don't see this as dumb and genius. What do you see as then, Magita?
No, I do. I said I do.
Oh, you do.
Is that
Yeah, we are literally okay. Before committing to this idea, Marinho, I think we should try to actually verify that this is actually allowed. I'm not saying it doesn't make sense to not be allowed. It should be allowed, but I think it's more prudent for us to verify that hypothesis before just committing to it. Would you agree?
I agree.
Okay, so
Uh,
how would we verify that? So there was a pipeline that it's been so long that I already forgot. How were we verifying things? I remember having
well,
a
we were
neural module. Yes, Marinho.
there's the tmp.erl that we're using, but I'm using that to parse an Erlang file and see what the AST looks like. What we need to do actually is take a hand-built AST that uses the silly variable that's named after a number
No, it's this
and
thing.
try to,
We need to put instead of forms, well, in a REPL, I mean, we need to put the var with the quoted 0 as a form in a program and see how that compiles, and then run the beam output file. Well, the beam bytes, isn't it?
uh, basically, yeah.
Okay, so what would be a program that add, and then we say A, B, and then I'm gonna say that the result of this thing
Is a plus b.
is A plus B. Then we grab that, we go to Earl. I need to parse this thing. So do you have, yeah, you have your function. No, but this is parsing an entire file. Can I have EPP form? I'm gonna assume this is expecting a string. The answer is no. So how do you parse the form again? There was a way to just do forms. You don't need a full file for that.
It's two forms.
Yeah,
Oh, to
I want to
I
parse
think
to the AST.
check on the channel. There is one there. Just go up.
Wait a moment.
Or actually,
Parse Earl
maybe
form.
on the. Let me see. I think
Returns an
there's
extra link
one
form.
code here. Sega Saturn stuff.
There was a
Nathan
way to
talking about
just
Super
have a
Nintendo.
form. Man, I used
Nathan
it
I
to
talking
make the
about China.
prototype of the Hello World.
And it's somewhere here on the chat. Just gotta find it. The Lighthouse of São Bento do Oeste. SQL Server. Capybaras. Victor
Ah man,
complaining
fuck
about
it. I'm
TP
gonna create
connection.
another file just for this shit. So I'm gonna say add URL.
Oh, that sucks.
Add URL. Oh, that's not what I wanted to do. Add URL. There we go. I'm gonna call this add. I'm gonna export add true. Then I'm gonna say I'm gonna grab the function.
Wait, I think I found it. No, that's OCaml. Man, where is it? No,
There we go.
isn't the module you want URL parse?
The module URL parse.
Or see what is in there?
Parse term. Parse and scan. Parse form.
Here. This is what we want to try to compile.
Okay, I think it was faster. So what do? We do the same trick that we're using for the URL in OCaml. So let's see. Okay, ignore bin bytes. Oops. Compile forms. And I believe we just pass a string in here. Well, this is not actually correct because it needs to be a list, I believe. Needs to be a list. It's a list of what, Marinho? Do you remember? Let's see the documentation.
It's a list of forms, and each form is a tuple, basically.
Yeah, no, that part, that's okay, but it's a tuple containing what?
Well, in this case, I already wrote a form in the chat here.
Oh, so it's a list of forms, you just paste your stuff. Okay. Boom, boom, boom. Ah. Okay. Just to make sure the new lines are not going to be a problem, I'm just going to say paste, and then close, and then that, and then this. No module definition.
Don't you want instead the parse expressions?
Oh, right. This is not a full.
It's not a form. Yeah.
This is not a full program. This is just the function. You need to add the. You need to add a module as well, module declaration.
But then that's crap. Why this is
Man,
like compile modules instead of compile
I
forms?
remember doing these here, which is slightly different.
Okay. Oh,
But
but this
that's
is
not forms,
just.
right? This produces forms, but I think on the same module you do have for forms as well.
Let's see what this code that Mageta sent does. That's not what I wanted to do.
That's old stuff we had, by the way.
Okay, so let's assume that. Yeah, this gives you a full. This is already a form, right?
Yes,
But
but
that's
there
not
is another for forms, I think, on the URL parse.
URL parse forms.
Complete.
No, there is no forms.
Remove the F. Remove the F. Just the tab.
Parse form.
Parse term. Parse form.
Okay,
What does
but
that
what
give
are the
you?
arguments of those things?
Tokens. Oh, so just the list? Yeah, just the list of tokens.
Yeah, but Mageta, this is a different thing that's what you're doing. We don't want to parse the form. We want to
What do you want to
compile the
do?
form.
I don't even know.
Yeah, what we want to do is, this is of the form
But
of
you
the
want to
function.
compile.
Yeah, we
Oh
want to
yeah,
see if we
so
can
okay,
run it.
then you need yeah, yeah. Then you need the module and on etc. Yes.
Marin, do you already have it?
I'm working on it. 1 second.
Yeah, you need to
Compile.
do the shit that I was doing. So you create a file, then you put the file in your parse
What does
function.
it do, by the way? What does that parse form give you? Just run. I'm curious now.
Uh,
I mean, no, Lemus. Like the response that he gave you on the tokens, right? You need to put that.
ah, you want tokens here.
Yeah. What does that give you?
Syntax error.
Syntax before? What the heck?
Oh, it's because you
Before
have expressions. That doesn't work. We need to put XPRs in here. There you go. This
Oh,
gives you the
interesting.
parsed form. This is a form now, which is exactly the same thing that Marinho generated. But
Yeah,
this is
that's
already doing
interesting.
the
So we
trick
have a
of the
way to
var.
generate it now. Parse XPRs.
Man, but if this works, I'm gonna be so impressed. If this works. Marinho, don't forget to rename the things to numbers after you convert the things. Okay, so let me
Oh
explain to
yeah.
Magetta so you can understand Magetta. This program is an add function in Erlang. This function, but we
Mm-hmm.
swapped the names of A and B with numbers 0 and 1.
Yeah, yeah, I see.
What we want to do is to see if this compiles, and if it does, we want to run it to make sure that we can actually abuse the fact and exploit the fact that we are on a level below Erlang, which would be very nice. Like the fact that we can do things like that. I don't know how cursed, like if the community already has a standard that you should not do that, if it's allowed. Like maybe people that compile to the beam, they like to have a one-to-one correspondence with Erlang. I don't know.
Well, in that case,
Yeah, we are
the
gonna be hated, but well. What can you do?
Error. Bad argument.
Oh, it didn't work?
Oh, it's because I forgot a step. I need to do.
Yeah, what I think it's the easiest way, Marina, is just to make a file like this, use your parse function from the temp file, and then you grab this and you replace the vars with the numbers for the A and the B. That might give you error messages with the numbers as names. Yes, that is very fair. Marine, what do you have to say about that?
Uh, the numbers as names.
Yeah, assuming this works, Nathan is already 2 steps ahead. Assuming this works and we have a runtime error in the beam, right? So we already did all the checks from our compiler, and we are completely just dispatching the code to the beam, and you run it as a beam file. If you have something wrong, probably a programmer error, then the error message that you will spit out is going to be like even more nonsensical than normal. So what's your response to that?
Uh,
That would already be the case, right? Even if you didn't use numbers.
well, yeah. Let me
Uh,
just.
yeah, you can avoid that, Nathan. But then that goes to the problem that I was debating with you about the JVM the other day about, oh, you don't want to rely on the error message of the JVM? Easy, just re-implement it yourself. And I really don't know if you want to do that right now.
Mm,
sounds easy, like just a million years in development.
Well, Nathan's wet dream is like the error, you do all the error messages yourself. You don't have to rely on that bullshit. And what I told him was exactly what you just said, Magit. Sure. Uh,
By the way, on
Uh,
that parser, can you send like text with module and those compiler directives like up there?
wait, could you
Does that
repeat the
work?
question?
Like those things with a dash, right? Those are
Oh, here.
some of them I think are compiler directives, but what happens if you feed that to the Earl scan? Does that work?
Euro scan. Oh, you mean
I don't
this?
know if we ever.
Let's
Yeah,
check.
just curious. Never tried that.
So
there we
if I
go.
I gotta change the tokens variable, by the way.
there's a dot.
Yeah, I need to change the tokens
Ah,
and the end location as well.
yeah, it works.
Ah, interesting.
Okay.
I mean, they
Okay, so
parse, right?
Marinho
Doesn't
already
mean it's
did everything that is required to make this work. So okay, can I just copy paste this, Marinho? Maybe.
Yeah, you just run this.
Okay. Something happened.
Yeah, now you should be able to call add colon add and do something.
Yeah, but there is a. Okay, add beam. There it is. But now I need to load this thing. So I think it's add. Okay. And if I do that, and I do that. Okay, so it does work. Okay, so we proved that Marinho is a genius again. Okay, not a surprise. Okay, so now that we
he's
have this
looking at
piece of
the brain.
information, what do we need to do? We
Marinho is
need to
literally
do
the brain.
this.
We're just pinkies, man.
We are just what?
We're just pinky.
Oh yeah. We are all just pinkies. Okay, so let's. Well, that's actually not true. You're also very smart, Magita.
And I don't know. Don't feel
I
like
know,
that
and I'm
sometimes.
telling you. We need to do the same kind of thing, but instead of generating variables, we just put numbers. Right, Marin?
Uh,
Agree?
right, we need to do. Yeah, we need to do. We need to generate variables whose names are numeric strings, like just the digits 0,
Yeah, we
1,
probably
2,
would
and so
do
on.
some sort of. Yeah. Don't forget me to increase the size every time. So let rec, we're gonna say rename declaration. And this is gonna receive. This is probably gonna receive a declaration. So decal. And what is the type of that? AST decal. And what will be the output? This should also return a decal. Right, Marin?
It should, yes. Basically, what we need to do is we need to look at the argument lists for each declaration.
Yeah.
Um,
So first of all, let's get things out of this guy. So we have a head and a body. That's not how you do that. So the head is a func. And a func is what again? It's this thing. So we have a head and we have that. So the arguments are essentially the elements in here, right? These are the arguments.
yeah.
Okay. So let's extract that first. So args, decal args. This is gonna be head elements. What else? In. Uh, we and this is a list of funcs with lists. Wait, we're gonna have to generate dummy locations, right?
Dummy locations. No, we can just reuse the locations of the arguments.
No, 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 no. We're gonna use dummy locations because we're gonna introduce clauses in the body of the declaration with the equals.
Well,
Closes
yes.
in the body of the. Oh yes, true. Let me find them.
Okay, so what do we need to do? We need to match, and we need to recursively, we need more recursion, I believe, right? Because we need to pattern match on this list now and recursively change the things, right? Or we can just map over it, right? So new args.
Map over it.
Yeah, we can just do map and there will be a function here and we put the declare args in here. And this function will essentially go through these elements, each one individually. And if it's not a variable, if it's a variable, we need to rename it. If it's not a variable, that means that it's pattern matching. And if it's pattern matching, we need to do something different about it. Agree?
Yes, if it's pattern matching, we need to replace it with a variable and add the explicit unification to the body of that argument.
Uh-huh. Yeah, so let's actually make a function called rename arg. And that will take an expression, which I believe is AST_XPR. And this should return a tuple of two things. It should return the new, um, the variable. So I think we can even do var in this case. But it should also return a list of things that we need to add to the body if it's not a variable. Agree, Marin?
Actually, we still need to add a list to the body, even if it's a variable, because actually,
Because?
do we want to rename that variable in the body as well? Because we could.
Oh, you're saying that we could just do the equals with their original name and keep everything else the same, or we replace the entire variable in the body as well. That's what you're saying.
Uh, yeah. The only problem is if we have two arguments with the same name in the source code, we need to unify those explicitly, and that we can't do with just a map.
Wait, repeat that?
Like if we have two variables with the
With the
same
same
name
name.
in the argument list, we need to unify those. And map doesn't work for that because it only operates on one argument at a time.
I see, I see. So what would be the best approach? Which function am I, which high order function I'm looking for?
Probably a fold because folds are universal, right?
Well, but that's, well, of course. A fold will definitely do it. So fold left, and this is what? An empty list? Yeah, yeah. Then what's your idea? We do a lookup? Like we iterate
Mm,
over them and we keep doing lookups to see if there's anybody else with that?
to see if there's anybody else with that. Actually, we only have to worry about the arguments, like the top level of the arguments, because if the arguments have nested data, and that nested data has variables with the same name as other argument parts, that should already have a unification in the body, probably.
I'm not so sure.
Hmm.
This is tough. So we have a list of arguments. So let's actually put an example here so everybody can. It's going to be 100% explicit.
You know, I was debating now, think of what Marin was saying, and I think the natural abstraction from Clojure to deal with the laziness and the permutations and etc. would be transducers, no?
Transducers. You could use transducers, yes, but
Because we're
um,
basically concerned with generating, well, composing uh, reducers together, right?
yes, you could use transducers for that. You could also just use lazy functions, as lazy sequences, I mean.
Oh yes, but then it's just a chain of applied function calls, right?
Yeah.
I'm thinking of how to do the You don't need the bar on the first, by the way, so that was correct.
Okay, so if it is a variable, let's actually do this as a to-do. So fail with, because this is one needs to do the search as well. So that's kind of fucked up. Variable renaming. If it's a functor, we already know what to do, right? Because
Um,
we need
there's
to.
a janky way to do the variable renaming actually.
Okay, go for it.
We can just say, okay, I'm going to rename only the arguments to a number, and I'm always going to add a unification with the original name to the body. Then we don't have to touch the rest of the body at all.
No, yeah, but I thought there was a trade-off about doing what you just said and doing the replacing in the entirety of the body. I thought there was a trade-off.
There is. What I said is easier for us to implement, but it's less efficient for the generated code.
Well, but that sounds more like an optimization. OCaml is fast. Later we can replace it.
No, not OCaml. The beam, because the beam is actually the one that's going to do those operations.
Well, not really, because the OCaml part of it is adding more stuff to the like we're adding unnecessary equals potentially, right? If we do with the dumb approach, there may be equals that we are adding to the body of the declaration that they wouldn't be there.
There will be, yes, but on the OCaml side, the only thing that adds is it makes the body of the predicate a little larger. So as far as
Which,
performance on the OCaml side goes, that doesn't matter too much. It does matter for Erlang though, because Erlang is the one that's actually going to have to execute the body.
yeah, no, that's I agree with that. But if the OCaml one generates less like external parts in the body, then it's less of a burden to the Erlang one because there's less unification to be done. That's my understanding.
Uh, but Erlang doesn't, OCaml doesn't do unification though.
No, you're not getting. So let's say that we're doing the dumb approach. So what would that mean? That means that we're doing equals 0, I guess. Well, this is not, this is a pseudo syntax. Equals out true
And
and
equals out 3
exactly.
because it
So
appears twice.
if we don't do it like that, this is the dumb way, agree?
This is a dumb way, yes.
If, and by the way, I should not swap these. Well, I should swap these, but this is missing a, oops. This is missing a, it should be like this, right? So, there. If we don't do the dumb way, are we going to generate the same amount of extra unifications?
If we don't do the dumb way, well, this is actually an edge case because this has a unification between the arguments. So
So,
we would still have to unify 0 with the first argument. We can't avoid that because
yes,
that
yes,
could
yes.
come as a variable. But we could unify directly arg2 and the arguments 2 and 3, and then pass either 2 or 3 to net instead of generating an intermediary
Exactly.
variable for
So
them.
what we would do something like removing that, putting true here, and putting I don't know true here. Okay.
Basically, yeah.
This is less things for the Erlang side to do. That's what I
It
meant
is.
by saying that the
Yeah.
OCaml one can help the Erlang one because we can generate less stuff. That's what I meant. But again,
That is the case, yes, but OCaml will have to do more work for Erlang to be able to do less work, you see.
but that's the good part because OCaml is fast. So if we have to do more work, I think that's not going to be a huge impact in comparison to the runtime of the Erlang side. Like in my mind, the bottleneck will definitely be the beam, always.
Okay.
Okay, but we're gonna go with the dumb way for now, right? So we're gonna do exactly this thing. So you always grab the first. It doesn't matter if it's a variable or not. So we can just say, um, I don't know. We can just say that's not. That's weird. Why that's my multiple curses is not working?
By the way, the return type is wrong. The right side of the pair is a list of expressions, not declarations.
Expressions, not declarations.
Actually, is it? I forget what the type is for the body of a predicate.
A body of the predicate is here. A body of the predicate is a bunch of functs. So that's what we're gonna do. It's written here. But we need the location. So that's where the other problem starts, right?
We can reuse the, yeah, we can just reuse the locations of the arguments.
Arg, and then we can just say location of the arguments. You say. Oh, you mean?
Yeah, yeah,
You
because
mean?
this generated code is being generated from the argument expression in the
Yeah, but we have
declaration, right?
locations only about these, and these. We are not like we're gonna use those locations for these people.
Well, yes.
Okay. In that case, what do we have to do? I need to pattern match. These are contents, right? So content. So I should say this XPR is with location, right? Yeah.
And by far, this is the most boring part of this project.
What? Which part?
This is just like this conversion of structure to structure. This is just
Well, man, you can you can't always have the fun. Um, so I also need the lock, right? And then I say content, and then I can remove that. And then I should say what? I should say that the new var will be a number. I need to receive the numbers and arguments, don't I, Marin?
You do, yes.
So counter in. I'm also very slow because I haven't been programming because, well, you guys know why. Uh, I need to return a new XPR, so this will be content equals. I need to return a new XPR, and let's just say the location is going to be the same. So what's going to be the new content? The new content needs to be an expression prime, right?
Yes, in this case, we need to make
A
a
variable.
var using the string of the int, which is the counter.
Yeah, so this is going to be string of int counter. I am doing something very wrong, which is the off. Okay. And then we need also, so we're always going to add stuff to it, right? We're always going to add. So we don't need to
Yes.
return this. Or do we?
I mean, we do because we need to say what should be added to the body.
Okay, so comma. And now what needs to be added to the body? It needs to be added a functor. So it's ast functor with a func. So I need to make a record now. A func is a nameF.
Which in this case is going to be EQ because it's the predicate name, right?
Yeah, but then I cannot just do what I'm doing. I need to get the shit out of this. So nameF equals
Well,
arg.
actually, no, you don't.
What do you mean? Oh,
The
this is
name,
already the content, right? I need to put the entire content in the functor. You're right. So this is going to be EQ.
yeah, the name f is going to be EQ. The first argument is going to be the same variable that we're putting, that we're constructing for the argument, right?
Arity is always true. And why is this wrong? And this does need to be a list, by the way, because it's always a single expression at a single expression at a time. So this can just be this. But this is a functor with location, so that means that this is content. And the location that I will be using is the same, you said, right?
The same location as the argument because that's the source that we're using to generate this code.
Uh, I am doing something very wrong, but I don't know what yet. Var func arg int. Yeah, I don't know what I'm doing wrong yet. And then this needs to be a list of expressions. So this is wrong actually. This needs to be like that. And then in here I put what? Arg?
You have to put the arg and also the same variable that you were constructing for the contents on
Yeah, I
the
should
line
do a
above.
let new var, and then the new var is this. In new var, and then I put always the new var first. Okay,
I'll
so there
be
is
right back.
something very wrong with this OCaml. Variable arg must occur on both sides of this pattern. On both sides. What do you mean? Does anybody know what I'm doing wrong? Oh, that's not how you do that. Yeah, what am I doing wrong? This
Uh,
type is an expression prime. So I'm pattern matching expression prime right now. Expression prime is what? Is this thing. So that's okay.
Actually, do we even need to do this pattern matching? Because we're just gonna do the same thing in all cases.
Oh, so you just want to use the content all the time. That is okay. So we can just do it like that, I guess. And instead of arg, we just put, yeah,
Content.
content. Uh, why is this broken? This record expression is expected to have AST var. Oh, var doesn't have location. Yep. Var doesn't have location. Do we care about not having location? I don't think we do. So we can just simplify this.
Uh, we probably should add the location there though, because this is going to be replacing something that has a location, right?
Yeah, so we
So
can
the
just
type.
reuse it. We are just swapping the var, but the location is already, because we're gonna use this in the fold, right? This is what we're gonna use.
Uh,
Whoever is calling us already has the location for that. That's my assumption.
well, whoever is calling us is already giving us the location as part of the first argument, no?
Fair enough. So you want to put this here. String of int is not a thing. Int to string. This is expecting what? A var. And a var. Oh, a var is not just a string. That's my problem. I need to put this in a name v. Okay, there we go. And then this I need to put location add. Ooh, we don't have a way to make that. I thought you added that in your code. Add lock. And this
Uh,
receives v with a and returns a with a location. But this also needs to receive the location itself, right? So we also need location, which is,
which is a T.
yeah, there. And then we just say,
Curly braces,
no,
content
no, no, this is not
equals
a t. This
whatever.
is not a t. This is location.
Oh, there's a location.
Yeah, and then
Oh,
what
you're
we
right.
need to do is content equals to v, and then lock. There we go. So then we do add lock, and we put the location there.
And that means you can get rid of the record around this thing, right?
That means I can get rid of the record. Yes, I can.
Yeah, don't forget
There.
the semicolon, yeah.
Then we do this. I want to compile my program. Dune exec Karuta.
You can just do a Dune build as well. That also works.
Dune build. Yeah, the preprocessor is still fucked up. Let's. Okay, there we go. This expression has type expression prime with location, but an expression is expected to have type ast.var with location. So I'm doing something wrong. The type of this is an expression, not a var. So we need to remove this.
Ah, all right. Yeah, that is right, actually.
Like that. This expression should not be a constructor. The type is ast.func. What do you mean?
Yeah, don't have the ast.functor there. Just get rid of that, because that's for injecting a functor into...
This is another expression thing. I see.
Yeah.
Man, I'm gonna do let ast let open ast in, and we can just get rid of that. We're not using the content of the argument anymore. That seems wrong. I wonder why.
You are, but it's underlined in red for some reason.
Yeah, but what's the problem with that? This expression has type A, and B, but an expression was expected to type expression list.
Oh, it's because you have a comma there. That should be a semicolon after the end of the list.
Ah, here. Okay, now this is the problem. Now I need to put variable in here. And now I need to put is that how you do that? I think it is. And you can just do this, right? Because this is a list of expressions. That's why I was doing the...
I see.
Yeah, so... Yeah, let's just put that back. I think that's more productive. Then I'm gonna say xpr here with location, so I don't need that. And what I'm doing here is the body. Yeah, this is the new equality that I need to add. That's what I'm doing. Let's make this an expression as well. Then I can just say, yeah, this, but then I need functor here. Awesome. And then I can just do that. Okay, what is the type of this? Expression prime. In that case, I'm just gonna do this. There, there. Boom, boom, boom. There you go. Okay, this took a bajillion times, but my disclaimer is that I don't program in OCaml for like almost 3 weeks. Actually, 3 weeks. Okay, this is it, right? This is the function that we're gonna use in the thing.
Yeah, this takes an expression, which is going to come from the argument list, and a number. And we construct the equality, and we construct the variable for that with that number as its name. Yeah, this should be it.
Yeah, but there's a problem. We still have to figure out how to unify these two things.
We don't have to.
What do you mean?
Because we're going to exploit the...
This name and this name.
Yeah, they are the same, you see.
I see. Very nice. Okay, but don't we need to swap this?
Why?
Okay, let's actually see the final version of this thing. Well, this 0 is misleading. I'm gonna put quotes.
Yeah, also the
The
body
3
is
doesn't
one
make
based for
sense.
some reason.
I was Erlang minded. There we go. Okay, so let me see if I understand. We are introducing a new variable artificially now. We rename those, which is going to be the first of this pair.
I mean, we're not really
These,
introducing it because it was already introduced in the source code, right? We're just pushing it down from the
no,
argument list to
we
the body.
when I say I am introducing, I mean that we are putting more burden on the Erlang runtime, on the MicroKanren runtime,
Right.
because this is going to have to be done via the conjunction primitive thing. All of this. Because I'm not like I don't want to like prematurely optimize this, but I want to have this in my head.
Okay.
Okay, but if that's the case, this means that we can fold now. We can just fold. And we need the accumulator will accumulate two things, actually. It will accumulate the things that you need to put in the body later, like pre-append it, and the new list of arguments. So let's make the accumulator like this.
Um,
And let's say that the lambda,
if you're gonna use lists, you should probably use a fold right, actually.
does that matter? It doesn't matter.
It it matters only in the sense that this avoids having to do a reverse.
Yeah. So the fold right actually sees the element first. So this is an arg, and then we have our accumulator. So this is gonna be new args, and this is gonna be uh, um, to append. I don't know. I have no idea. Then what we do is we call the new arg. Well, we're gonna get the new arg and
I'll be
what do
right
you
back if
call
you want
these,
that.
man?
Oh, what do you call this? Um, you could just pass the body of the predicate there
The
as
body
the
of the
initial.
predicate.
Like instead of passing an
Oh,
empty
you
list,
mean you mean like we pre-append it as we go forward.
basically, yeah.
So cons. Okay. So this is gonna be I'm gonna say body prime because why not? And then this is to append. Rename arg. Well, we need a counter.
We need a counter, yeah. And the counter.
Counter.
Uh, oh, this is gonna be backwards, but I don't think that's a problem.
Ah, we could use the length instead. That's what you thought.
Ah,
Um, and then we pass the counter. This will give us those two things. And what we need to now dispatch the new accumulator. The new accumulator is simple. It's just um,
new
new
arg,
arg,
colon, colon, new
cons, new
args.
args, comma, counter plus one, and to append colon body prime. Why is this wrong? Do I have extra parentheses? Am I mixing syntax in this? Fold right. Oh, this actually comes before in this case. Okay,
That's super weird.
that's very weird.
Actually, the list comes before the accumulator even.
Yeah, that's what I just swapped. The list
Why?
comes first, and then the element, argument. There is some scoping problem going on.
Why is that the argument order? That doesn't make any sense.
What am I doing wrong, people? Help me. Help me,
You're
help me,
taking
help
the
me.
arg, and then you're taking the triple. then you're using the counter and the arg, and then
Is this not how you do fun? No, this is fun. Then the thing, and then arrow.
real quick, there's an in on line 92. Put something after
Ah,
that.
no. There. This
Oh,
language
there you go.
doesn't. Yeah. Ah. Okay, so what is the type of body? Oh, this is a functor with location. I need a location.
You need the
I need
location.
location to be in the. Wait.
You can just change the return of rename arg to have the right type, no?
Yes. So okay, so this would return what? A func
Func with
with.
location.
Yeah, so location with location. Now this is wrong. And the reason this is wrong is because this needs to be like that. Yes. That's it. These are the new. Actually, this is doing more than just that. This is doing the new args, then don't care, and then this is the new body, right?
Yeah.
And then we need to reconstruct a declaration now. So let's do that. So a declaration will be, this is not prime, so there must be this. And then a declaration is this thing. So we're gonna do head equals. It's a simple func, and this is what? This is an expression list. So I need to create the functor myself. Cool. So this is gonna be what? Name f.
You can just say head with and then just override
Yeah,
the
with
elements.
elements equal new args. And then I do uh, no, actually that's right. And then the location will be what? Who has the location in here? This is a functor.
And wait, doesn't the decal have the location as well?
No.
It doesn't.
Yeah, we assume that it doesn't because the decal the the decal that has a declaration is this declaration here. So this is the location of the first declaration, the first decal there.
Oh, in
So
that case, you shouldn't need a location around the entire thing.
mm,
Yeah, you can just return the head with elements equal new args and body equals new body, I guess.
you're right. So we just do, oops, we do that. Um, oops, body equals new body.
Yeah.
Why is this uh, that? No. Oops. Let's put this in here. Uh, this
Hmm.
record expression is expected to have type decal, but there is no field within type blah blah blah. So what is the decal again? Is a head and a body. Why are you mad at me?
You look bad. You look ugly.
Elements is what again? Head is a func. Oh, this is a
Ah, no, you
func.
have to.
So I
Yeah,
need
no,
to
you have to
keep the other
do.
things. So I need to say,
Yeah, no, you have to do head equals, and then you do head with
yeah. Then I do, um,
elements equal new
Uh,
args.
yeah.
so you guys are just translating the.
There we go.
Let's
What
see.
we are doing is the following. With this, okay, so there are two approaches to solve this particular problem, Magita. The first approach, which Marinho agrees is the naive approach, is to not care about whatever is going on the argument. So if it's a variable or if it's a functor, if it's a literal, it doesn't matter. We always rename it, and we always add more equalities in the body of the declaration. Why is this bad? Because this is potentially adding, like, this is adding a lot more stuff, a lot more
Yeah.
equals predicates, so the beam will have more of a, like, it's gonna
Yeah,
perform
it's more
worse.
instructive overall to work with, right?
Yeah, but and then in the future, to optimize this, what we can do is to actually inspect if this is a variable, and if it's a variable, then we do the equals, but then we have to care if we have the situation of like, um, where is the example? Yeah, this particular situation, that you have two variables that need to unify among themselves.
Mm-hmm.
We're gonna have to care about that as well later. But to just like do it as fast as possible, this is mechanically easier, and it will always work. It's not free lunch because you have to pass this to the beam, to the MicroKanren thing. But we successfully renamed the thing. So now it's just a matter of doing the fold. So rename declaration. Then we go here and say, rename this declaration, please. There we go. Can I remove this to do, Marinho?
Yeah, you can.
Okay, and I have another question. This is only a particular pattern match, right? So in the case that we have a declaration, we don't care about anything else, do we?
We shouldn't, no. Actually,
Oh,
do we care about...
unused rec flag. Go on.
We should probably do a rename declaration on the generated declaration of the query as well, because we generate an artificial declaration for that, no?
Yes, it's it's in here somewhere. Declaration, here it is. So,
Although,
yes?
do we need to do it though? Because the query is always going to have, we are always going to add variables as the arguments. So
Does it matter?
I think it's, I think it's probably fine to leave the query as is actually.
Okay. Cool. Very well. If it's easy to change, if you ever need to change it back. Well, use this function. Call this function there. Magetta, I'm gonna just quick overview what we did during probably your dinner. We fold through the declaration body,
Mm-hmm.
and we keep accumulating we will accumulate the new head essentially, because we need to pick the head of the declaration. So the head, I mean this, and
Yeah.
we need to save the new names for these.
Mm-hmm.
Um, then and we need to append the equalities on the body. So that's why this is here. This is the counter that we're going to keep incrementing as we move forward. And then what we do, we also created this auxiliary function that grabs an expression, which right now we are not inspecting because of the dummy way, and we will return the new name of the argument and the equality that you need to put in the body. So this is the new variable that we're going to that we're going to use in the argument list of the predicate, and this is what we need to append in the body. So this is the equal. And then this is the new variable that we just created. So for example, 0 in quotes,
Mm-hmm.
and this is the old name, regardless of what it was, if it was a variable or a functor or a literal. And then we keep appending to a list of new arguments. We keep incrementing the counter, and we keep putting things in the body. This is a fold right, so the order is right. Then we just put the new arguments as the new argument list in the head, and we just swap the body with the appended equals. That's it. And
Wait,
then we
the
just call it here.
body. Oh, I see. Mm-hmm.
Okay, now the compiler. Well,
I was thinking about renaming and error reporting because we are renaming, right? But since we can just transparently go from one to the other uh, by association and it's by location, right? The name I think it doesn't really matter at that point.
Yeah,
It just matters for our.
yeah, the locations will still refer to the original source file regardless.
yeah.
Yeah, so
Yeah, but the error message, we need to be careful about error message now, because we cannot just speak naively the the name v of a variable in a particular process of the compiler, step of the compiler, because we need to remember, oh, the names are useless now. They will not refer to things in the source code. So we need to be careful about the error messages only. The locations are fine. Cool. So now we can come back to compiler. So there must be a function here. Where is it? Yeah, compile
Is that a
body.
missile?
That was
Are they
a
are
plane.
they
Yes.
finally detonating your city? Please tell me they are.
Okay, so compile body. I already lost the memory that I had about what we were doing in this thing. So this is compiled. This is compiling a declaration. Yeah. Then okay, before doing any of that, actually, I have a proposal. Marin, what do you think about creating like something like this? And then we can just have functions that compose the other AST in OCaml.
Functions like, what do you mean like this?
Gis, conj. Instead of having to write them by hand, we just make like helpers in this module
Um,
that will
okay,
already do
sure.
the AST like very because writing that by hand in here is gonna be pain. So
That's okay with me.
okay, so this is what runtime. Yeah. So is this the file that we? Yeah, this is the file. Okay, so let's start. So what do we need to do? Let's start by m plus. So this is a thing that takes a pair, takes two arguments, right? So this and this, and it needs to return the what's it called? Abstract format. Is that how you do that? Format. I don't remember how we were doing that. Compile body, compile declaration. Yeah, this beam builder. What is this returns? A form. We need to return forms, right, Mani? From there.
Basically.
So yeah, so where are we? Yeah, there we go. So that, we need to return form T. What would be the types of those? It's a good question. These are also need to be forms, no? Like this is a list in Erlang, so we need to keep already translate
Wait,
that.
wait. You're going
Yes.
to... We're not going to use them plus directly.
Um. Oh, okay. So my bad. Which ones we need to do directly? Start, right? In the
Um,
beginning of the compilation process.
we're going to need start for the query, yes.
So start, and then this doesn't have. These just have an arg. But what's going to be the type of that? That's kind of my question.
Start will need to take goal, which is...
Just a var.
No, a goal is either a conjunction or a disjunction. Or it can be a primitive goal as well.
It could be a
I guess
primitive goal.
technically, I
Okay, let's
guess
actually start
technically,
with equality. I think that's easier then. Yes, go.
left hand side, right hand side, yeah, it's going to take basically...
This will return a being. This will return a function of some kind.
No. Oh, wait. Let's back up for a second. This shouldn't return a form. This should return an expression, actually.
An expression? I'm confused. Which expression are you talking about?
EQ is a beam expression, not a beam form.
Oh,
At least for the purposes...
but if you compile this, you're gonna get a form. Well, not if you compile. If you parse it, you're gonna get a form, right?
If you parse... Well, if you parse that line 161 on the right, you will, but we're not going to parse that. We're actually going to emit calls to EQ, not parse EQ.
Emit calls. But the act of emitting that is already a form, no? A function
No,
call
no,
has a form.
no. A form is a top-level declaration, or it can be one of the module attributes like import, export, whatever, right?
Ah, so that's my confusion. You're saying that. Let me go back to core. So type form. Maybe it's module form. There we go. These expression. That's what you meant.
Yes.
Okay. So this is this.
Yes, and the
Mm.
left and right hand side are also expressions.
Okay. So yeah, but then that means that we're gonna have to compile the right hand side and the
Wait,
left hand side.
what? So you guys are doing now primitives. You forgot the let, by the way. So now you guys are
Let
doing
yeah. What we're doing is the
primitives
following.
to
We
emit. Is that it?
yeah we I'm trying to make because we're gonna be using these all the time. Let me put the example on the screen. What the fuck? Yeah. We're gonna be emitting those all the time, Mageta, like conjunction, equality, disjunction, call with fresh. So I just want to make helpers because then they can compose a little bit nicer. I don't want to
Instead of
be
just having to do a
yeah I don't want to be
fun.
writing all of these myself every time.
Well, why not? That sounds cool.
Ah, okay. So
Well, I'm
then
not
I
sure if you're gonna be able to eliminate a bunch of the. Well, let's see. I don't know what you're thinking though.
okay so there apparently something wrong in here. Expecting dot unbound module form dot xpr. What?
Let me
What
see.
am
You're
I
applying
doing
up
wrong?
there. Fun. That
Uh,
looks like it's just hallucinating.
oh, okay. Okay, so what do we do now, Marin? We need to. Well, we have what do you call expressions, right? That's not it.
Yeah.
Yeah, so we have Erlang XPR. So what is an XPR in the Erlang module? It is. I mean, this repetition pisses me off so much. Uh, where is an expression?
It's all the way in the top, I think.
Really?
Well, unless it changed, I don't know. Wait.
Yeah,
Ah,
here it
there.
is. Okay, so we need to pattern match all of these now, right, Marinho?
No, we're going to construct one of these. Why would we need to pattern match?
We're gonna construct. Wait. Oh, you were right. We need to construct EQ. Where is it? This EQ. I need to construct this.
Yeah, you need to construct this, basically. Well, not exactly this. You need to construct the EQ that will be in the body of whatever predicate we're compiling. So you need to compile a function call, basically.
Okay, so this is what? Beam, core. Actually, I think it's builder. Builder. And do we have a function call in here? Function. We have a function declaration. We don't have a function call in here.
We need to do a call with module, actually.
Call with module. Okay. So what do I pass to this guy? I pass the module.
Which is going to be Karuta, because we're grabbing the EQ from the runtime library, right?
Um, I guess that's fine. But how do I create one of those? That's kind of my call with
Um,
module. Call with module receives a T, and the
they
T
they are just
is
expressions, so you should be able to just say just use the atom function from the builder module.
Atom function from the builder module. So you're saying builder, well, I should put parentheses. Atom
Karuta, yeah.
Karuta. I see. And that's the wrong thing. Okay, and then we have the function. The function name is actually going to be EQ. Right?
The function name is actually going to be EQ. Yes, you need to do a named, actually not a named, builder. Call with module, not a function declaration.
Escape string, expression, string of literal.
Oh, I don't think we have a helper to make a named function yet, but we can just add one.
No, yeah, okay, but that would be what here? So let function call name. What do we need to pass to it? That's kind of my thing.
Not a function call, a named function. Wait.
Named function.
Actually, one second. I think call with module takes a name and an f, and the f is an expression. What am I saying? The f can just be an atom as well, actually.
Okay, so you're saying that I can just say
Yeah, it's going to be builder.atom eq.
that. Oops. And what is the args? Should be a list, right? So it should be LHS, right HS, something like
Yes.
that. Okay. So we need to do those for everybody, for every one of these things. Okay. Does this compile by any chance? The answer is syntax error. Syntax error, where?
You should probably just do let open builder in this place.
Open builder. There we go. What am I doing wrong syntactically here?
And you also don't need the module form because builder exposes that, I think. And you don't need the form dot because it's open inside of.
Expecting dot.
Wait, expecting dot.
What am I looking at here?
Huh?
LHS, that should be.
What the
Unbound
fuck?
module.
Oh, those should be
So,
expert.t on both sides actually.
Oh, those are modules. That's my
oh,
problem.
right.
Yeah, but I think we do need the other thing though. I think we do
Do
need
we?
this because we need to apply the Erlang thing, the Erlang module to the form module. So we kind of need to do this, I believe. Yeah. Cool. There
But
it is.
isn't? I mean, theoretically, the builder is already doing that.
To build the form, right?
The builder is already doing that.
You do need this here because you're well, unless you do this inside the builder, I guess you will have to
Like
do this.
the builder has an open core form core Erlang. So if you do open builder, we should have access to that, shouldn't we?
Like this.
Yeah, but then form should not be a prefix.
Like this.
As far as I know, when you open something, it doesn't open the dependencies that it has.
No.
That
He's saying that builder already is doing this. So why do
Yes,
I
but that
have
doesn't
to
get
do?
but that doesn't get imported over to the other module, right?
that's weird and
Oh,
inconsistent actually.
that is correct. It's just it's
But
not an expression, right?
can I just do this then?
Yes, if you do this, then it is an expression. Then it will load.
Okay, so then if I do that, okay, it's not. Yeah, Marinho. Yeah, Marinho. It's weird. Okay, what's next? EQ done, right?
Well,
We're
it
just
is
calling.
just weird because the default behavior is of languages like C, it's to include everything, right?
Yeah.
It's treating as values on the.
Call with fresh money.
Yes, we're going to need that. We're definitely needing that.
So call with fresh. So this doesn't need. I'm gonna put. Should I put an arbitrary expression here? Because this should be a function.
Yes, because we're going to generate this from the Karuta EST, right?
Yeah.
So we should be safe from that front.
No. It's just because I'm feeling that the expression dot t is too like it needs to include more stuff than just functions. Can't we just like
Um,
specialize this to be just functions?
um, I mean,
Sure. Always fresh. What do you say, Money?
we could try, but then we won't be able to just use call with module.
No, we would transform whatever is coming to an expression t here. That's what I meant. We make the API safer for use, but we do the transformation to xpr.t ourselves in here. That's
I mean,
kind of what
sure.
I thought. Yeah, but how can we do that? How can we do that?
We need to do. One of the cases of XPR is called fun, and that has a payload. We need to take the type of that payload instead of an XPR.
Oh, this one, you mean?
Yeah.
Okay, so func. Do we have access to that? We should, right?
We should.
Yeah, these are the only things that f can be. Am I understanding this correctly?
Yes, you are.
Okay. So in that case, we can just do func. This is not gonna type check, but then we can just do fun that. Nice. Okay, now disjunction and conjunction. We're gonna have to. OCaml doesn't have overloading on arity, so we're gonna have. And I know we have, yeah, disjunction on 2 and disjunction on 1.
We should just use the list
Really?
version.
You can put a optional as an argument.
Yeah, that's also fair enough. What did
Like
you say,
I
Mari?
mean the.
Go on, Mageta.
No. Let me send you an example. That's better.
What did you
We can
say,
just
Mari?
we can just compile down to the list version, the single argument case, because that takes a list.
Ah, the disjunction with arity 2 is just to like combine. Yeah, just to do
Yeah,
this.
the arity2 is the primitive, and the arity1 is the fold version, basically.
Okay, I don't know the type of that yet. XPRT. Nice.
Please don't get sick again. You can do like these here, Lemus.
This
If I can
should
type
be a
correctly.
list of stuff, right, Marin?
Yeah, it should be. Well, if you're willing to be as general as the Erlang type system allows, it would be a list of expressions, but we don't have a type
I see,
modeling
Mageta.
for
Thank
the
you.
goals yet, do we?
Actually, I forgot. What is the type of a go again?
A goal is a function, a monadic function, that takes a state and returns a list of states.
Okay, so this is a particular function with a particular type. Okay, can't we just say then that this is a list, like this? Can't we just say that?
Can we just say that?
It's not
Um,
correct, like in this, like strictly speaking, but it's better than just saying expressions.
We can't because in general we're not going to construct those functions using lambdas.
What are we going to be using to construct them?
Disjunctions and conjunctions and calls with fresh and EQ
Well,
and all
then it
that.
needs to be a list of this, right?
Yeah,
Pretty much the same thing for conjunctions, right?
pretty much the same thing for conjunctions. We just need to rename the atom.
Okay, what else do we need? Take all. Sounds like something useful.
We should probably add take all and pull for the sake of queries. Yes.
So take all. This takes a stream, which what the heck is? Which is a list. List of what?
Uh, well, it's not necessarily a list. It could be a function. So it needs to be an expression actually.
Yeah, you're right. So then we need to do something like that. This is take all, and we need to pass a stream to it. And then this is pool. Do we need pool? Because pool is already being used in take all.
Do we need pull? Probably not actually.
Yeah. Start we do need. So start should be a goal, but a
Don't we
goal
have?
is going to be conjunctions and disjunctions, which means it needs to be a general expression, which means that it should be like this, right?
Yeah.
Cool. Do we need bind explicitly? Or
I
even
don't
delay?
think I don't think we need either of those because conjunction and disjunction are already introducing them for us.
We have this, we have this, we have this. Yeah, this, 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 this. This is recursive, which is okay. This there. Call is fresh. And then this is just a tail call. Is that it? This is all that we need to like implement a logic language?
It should be, yeah.
Damn.
We're probably gonna need a couple more things to integrate with Domino, but to get started, this is enough.
Okay, now we can go back to compiler. Okay, so let's do 2 steps back. So we have compile, which take a list of clauses and needs to return a list of forms. It takes a list of clauses and a compiler, I should say. Then, if we don't have anything, this means that we are done. So it just spits the output. If we have something, we have a form and remaining. Wait, this is wrong.
We have a form in the remaining program. That's not a clause, Lemos, that's a form, an entire form.
That is not correct because this is saying that this is a list of clauses. This is the output, which means that these, yeah.
Okay.
Then we have the compiler. Then we're gonna compile to a form. Well, we should say probably. What is the convention in OCaml? Do people do transformation functions like this?
Just call it compile clause, why not?
You can say that a correct approach would be to put on the AST clause the to form, right? But whatever, man.
Probably.
You,
But
you,
AST clause is not a module, it's a type.
yeah.
It's a type. Okay. Well, you
Okay.
can have a module with the same name as the type.
Okay, but let's for now just do it like this. Clause. Okay, so then we have that, and then we check if the form. We check if the clause. I don't know how I made that, but okay. This is also clause. We check if the clause is a multi-declaration. If it is, we gotta go to compile declaration. So far so good. Queries, we don't do anything with them yet, so that's okay. And then compile declaration, what do? We have, what are we passing to this thing? Oh, we have a multi-declaration because we already pre-processed, which means that we have a list of declarations. We have the first and the remaining clauses. Yeah, here we use the correct names for some reason. Okay. Ah, this is why we did this. It's because this first clause now has location. Okay. Then we do first clause content head. So that is the first, that's the head of the first plus. So this is plus and this is 3. Then what do? We create a declaration saying that this is a function declaration in Erlang. This is the name of it. This is expecting an int, which means that this is the arity. Then it goes to the bookkeeping.
We
But
don't need that anymore.
Exactly. We changed this approach, so now we can just be arity. Then we say compile the body, please. What is this expecting? This is expecting a list of form clauses. Okay, so to not get confused, we have our clauses and the form clauses. Awesome. Then we just concatenate this back into a list. Sure. Compile body. We receive the affirmation list of list of declarations actually. Yeah, this is a deco, so that's fine. Then we match them. If it's empty, predicates must have at least one body. Sure. If there is at least one of them, okay, so this is the recursion that Marinho mentioned last time. We have 3 cases: empty, singleton, and many. Do we still need those 3 cases?
We probably do actually, because the 0 case is actually in fact unreachable if nothing goes wrong.
You wait. I don't. You. Oh, you mean that this is gonna be the base case of this call?
Yeah.
I see. Okay. So let's assume that you have a simple predicate. You have just a single plus for now. So this is the plus itself. This is the location. For some reason we are doing equals underscore. Then we need to call this junction now.
We need to call this junction. The base case for this junction with one item just returns that item, right?
Just returns that item, yes. No.
Actually,
No. We need
why?
to do the conjunction. No? Because let's imagine that you have plus 0 out. Well, I should not say that. We have this. EQ 0. Oops. 0. EQ 1 out. EQ 2 out. And then what is the last one? Net?
Net of out, yeah.
Out. Yeah. This is what we are doing, right? This is essentially what we have in this case. And this is a dot, because this is a singleton. So then we do it. That's what we're doing right now, right? My understanding is that this is a bunch of conjunctions. Am I wrong?
Yeah, each body of the predicate is a conjunction. And then
Okay.
the entire predicate is a disjunction of all the bodies.
Yeah. Yeah, but the disjunction comes here then.
We can probably just use a map, to be honest.
Wait,
Not
so
the map data structure, but the map function.
You're saying
basically.
if this, that, else, least map something, clauses. Is that what you're saying?
Compile. Although this is compile body, this is compiling one. Wait, compile body. Oh, this is taking the body from a multi-declaration, right?
Yes, I think we should be. This is yield named, easily named. We should change the name of that. We should probably say something along the lines of um, compile declaration, and this guy down here is compile multi-declaration. Yeah.
Actually, it's not quite a multi-declaration because this should also work with. We should it actually.
No, but a multi-declaration, if you have a declaration with only one case, it's still a multi-declaration because of the preprocessor. Doesn't matter. So then this becomes multi-declaration. And then up there, instead of compile body, we just say compile a single declaration for me, please. Then we know for sure that this function is handling only this type of thing.
Well, not quite because the way this is written, the compile body is basically compiling, is basically going to emit the AST for the body of the Erlang function, which is actually still in the context of a multi-declaration because all of the bodies of the predicate will go into a single function body inside of a disjunction.
Okay, so would you say that it's better to name this that?
Probably, yeah.
Okay. Cool. Okay, now we have this if, right? So that's syntax error. What am I doing wrong?
There's an exit one there that you should actually no. That's you probably need parentheses in the around the then.
Here.
Yeah.
I see. Okay, then we're gonna do this thing here.
Compile single body. Go.
Yes, we're gonna have to make that, but before we don't need this count anymore, right?
We shouldn't, no.
This was for the previous approach. So compile single body, and that's what we're gonna map here.
Yeah, and then we need to fold. Actually, that's going to give us a list, right? That means we can just use it to build a disjunction after that.
Yes, probably, but baby steps, baby steps. First of all, let's do the single case. So the single case, we're gonna have a decal, which is this thing here. So we just put it there. And what we're gonna return?
We need to return. We need to return an expression, an Erlang expression.
Okay, so beam. Wait. We already are doing the thing here. So we already have the builder here. Yeah.
We should
Beam,
already have the builder.
Builder. XPRT. But that's a list of those.
No, if you're compiling a single body, that's going to be a single expression because
You're
it's
right,
going to be
actually.
a
You're right.
conjunction.
Okay, so now we have a full declaration. So we need to deconstruct things out of it, right? Yeah. We need to deconstruct things out of it. Okay, so first of all, let's extract that. What's the problem there? Did you mean contents? No, I didn't mean context at all. Well, I'm actually gonna do that in here. So content lock. Cool. So now what do? We're gonna do the conjunction in this case, right? The things are already renamed, so I need the head of the thing. So content, head, elements. So these will give me the args. These will give me the args. This is an expression list, but we know they are all variables because the preprocessor already changed them. So that
Do we
means,
do we actually need to read the args here? I don't
yeah,
think we
because I
do.
need to go one by one, putting the.
The body already has that information, Lemos.
You're right. So,
What we do need to do though is we need to traverse the body to find every free every variable that's not an argument and insert a bunch of calls with fresh basically.
um, you are right. But to do that, we still need to treat the elements of the head. Um, do we have... we don't have an expression module. We should make... Oh, we do. Okay. So extract var. This needs to receive a t, and it should return to me um, a tag.
It should return a set of tags actually, no?
No, because an expression can only be a single variable at a time, and I
No, because
want
it
to
can be a
just get the name
it
out of it.
it can be a functor which may have a bunch of variables inside of it.
That cannot be the case because in the head of this predicate we already preprocessed, so these names will always be variables with strings.
But we don't care about those, we care about the other variables in the body.
Oh, when you said that we need to identify if the things that are appearing here are variables or are arguments or not, you didn't mean the arguments of the declaration.
We need to add calls with fresh for the non-arguments.
Yeah, so we need to identify which ones are the arguments. Agree?
No, we need to identify which ones are not the arguments because we need to add calls with fresh for those variables
No, no,
because
you are
they
repeating yourself. I understand that we need to do the calls with fresh. I understand that. My question to you is a different question, which is how do you know that this variable here is an argument or not?
you check if it's a digit string.
You check if it's a digit string.
Actually, you can just look at the first character. If it's an uppercase letter, it's definitely not an argument.
Okay, so your plan. Okay, let me explain to you what I was thinking. I was thinking about just doing a set of those and then just doing lookups. But your idea is better because it's more performant, right? You just go over the things. Yeah. Okay, so but how are we gonna extract all the variables of the body of a particular body?
Well, we have to return. Don't we already have something similar to that in the preprocessor? I'm pretty sure we do.
Remove comments. Check empty heads. Find variables. Uh, yeah, but that's not gonna work. We're gonna have to fold, I believe. Agree?
But this is already doing a fold.
That doesn't matter. This is taking a single expression. We're gonna have multiple expressions in our body, right?
Okay, yeah, we can just fold with a set union in that case.
Yeah. So we grab the elements. That's not gonna work. Map Emacs. Okay. Emacs. Don't screw me over. This, yes. Now
out of this ecosystem, the last thing that can screw you over is Emacs.
Actually, there was a comment in a recent video complimenting my Emacs.
Really?
Yes, they
That
said it's very pretty, apparently. Um, okay, so what do we need to do? We need to do a list, fold. I don't think it matters because it's a union anyway. Do we have bad sets in here? We don't. So, bat set.
Na 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 na.
Thank you,
What was
Marinho.
that?
Batman.
Ah! What was that? Set empty, and we're gonna go over the args. We're gonna go over the args. Um, okay, so now what do I do? I can compose things in this case, right? So the first thing we gotta do, believe it or not, is called the preprocessor. Find variables.
And it's super
Ah.
painful to look at company mode screwing up your window.
It is super painful, but I can disable that.
Do you have Corfu?
Yes!
Man, just enable Corfu,
What
please.
the heck
Like,
is going on down
it's...
here? What the heck is going on down there?
People just said nice things about your Emacs, and look at
Yeah, but
this.
what the fuck is that, man?
Control X1, I think it was the company
Con-
mode with the mini buffer.
no. And it
What
didn't,
the
it
hell?
didn't, what the?
Okay, now it's not
That
opening
is
up
new.
Helm, right?
That is new to me. Okay.
That's... Can you go to that buffer? Like Control X down? Oh, sorry, Control C down? No, you can't. So that is not a buffer. That's weird. I mean, it
Yeah.
must be, but...
Okay, so we need to do the find variables. Find variables expect an expression. So I can, in theory, but this is not a map, this is a fold. Yeah. Okay, so this Q
Uh,
buffer.
what?
Q
Control
anyway?
G?
No,
Control G?
I already did that.
What have you done to
Nothing.
open
I
that
was
up?
just typing.
Okay, oh, the thing on the bottom disappeared. I think
Yeah,
that was what I
vars,
could see.
vars, and what's the other thing? Vars, and then we have an arg, and I need to return the other thing. So the first thing we do is let more vars. We find variables using the arg. Then we do set union vars with more vars. There it is. So now we have all the vars. Marinho. We have all the freaking vars. Yeah,
Okay.
but this is kind of annoying because this is not stripping, like, this is not a set of strings, this is a set of vars. But that's
Well,
okay.
which is fine because we can get the name of the var. That's not an issue. What we do need actually is to filter the set so that all of the... Well, I guess technically we can turn the list of arguments into a set of variables and do a set difference in that case.
Wait a moment. What do you want to do again?
We need to get rid of any arguments in this set of variables.
Yeah, we already done that, right? No, we didn't filter, my bad. We just got all of them. So we got the elements of the head. No, of the head. This is wrong, right? This shouldn't be the head.
Args.
This should be
Yeah,
from
no,
the
we should
body.
get... No, we should get all of the expressions in the body, all of the functors in the body, and find all the variables in there.
Yeah, so this is body for sure. Which means that I probably what is the type of that? Yeah. Yeah, now I do comp in here. And then I need to, after stripping the location, So after stripping the location, what do I have? I have this, which is a list of funcs. I strip the location. Now I have a list of funcs without location. I need to extract the elements, right?
No, you can just do find variables, no?
Find. No, I cannot, because find variables expect an expression, not a func.
Well, in that case, you need to wrap the func into inside of an ast.functor, I think is the name of the tag of the constructor.
Okay, so let's do that. So find variables. You receive a func, and we're gonna do this. But we need to do ast functor func in, right? So strip the location, find the variables. This gives me a list of variable sets.
These you fold left with union, yeah.
Well, but in that case, I'm just gonna put this and then list fold left set union set empty and done. Right?
Right.
And then I don't need that. There you go.
We still need to get rid of whatever arguments may have been in the set of variables.
Oh, you want to strip the ones that don't start with a capital letter.
Basically, if it starts with a digit, we know it's an argument, so it shouldn't be in the set because it's already.
Set filter and receives the lambda. Okay, we receive a var. So I should say name v, ast name v, which probably means I should probably do a let open ast here. So I do that, and it cannot start. This needs to return false to remove or to preserve things.
This should return true if the
Name
first
v.
character of the name is an uppercase letter.
Okay. Um, uppercase letter. So string
Starts with.
starts with.
Although starts with takes a string prefix, right?
Yeah, doesn't take a function, which is very annoying. Starts with, contains, blit, capitalize, cat, compare, get. Is it possible to have an empty name v in this case?
Um,
Is
it
it
shouldn't
possible?
be. Hello, Commander.
Hello, Commander. I think it shouldn't be possible. No. Index opt. Oh no, this is probably the first appearance of the char. That's not what I want. Init. What the heck does init do? String module OCaml. That's not what I wanted to do. Init. Let init. Val init. Init nf is a string of length n with index I holding the character fi. Nope. No. We can use index from.
Index from.
Yeah, because it's saying is the index of the first accrued. Oh, but this is a particular character. Fuck.
Isn't there a module that handles regexes somewhere?
Oh yeah. It's in str, of course. Um, oh, just before doing that, let's just make sure it doesn't have it. To sec spell checking. It even has spell checking. Uh, seeded hash. Yeah. You want to go with regexes, Marin?
Yeah.
Hmm. Returns Allegro express string match. Test whether a substring of s that starts at position start matches the regular expression r. Yeah, we could use this definitely, right? Because we just say start is 0, and then r is the regex expression, and then s is the string itself. This returns a boolean, so that's good enough.
Um.
And that should just be something like this. Let's assume that is in a standard library. So str string match. We're gonna do a regex expression here. Then it comes the string itself, and then 0. This I don't want that, thanks. And
I
then we
posted a
just
thing
say
in the chat, Lemos.
there. Oops, there. I will check in a minute. Oh, it's the opposite, right? We need to return the true. There you go. There it is. So this is returning all the vars that are not arguments, right?
Yes.
Okay, so what do we do with them now? We need to fold over them with call with freshes, right?
Uh-huh. That's what we need to do.
We need to fold over them. So this is gonna be a fold. Wait. What? Fold, yes. And now we need to provide the function. So Aaron, oh, that breaks the pipe because the set is not the last argument.
Amazing.
OCaml. OCaml being OCaml. Okay, so in that case, we're gonna do in, and we're gonna go fresh vars.
Actually, this is going to compose the entire expression, no? Because like we're gonna do a fold over the set to to basically wrap the base case of the fold with calls with fresh, right?
Yeah.
So I don't think you need this let actually.
This is gonna be just a return of compile single body.
Yeah.
But I have a question.
Okay.
Don't we also need to compile the EQs that we already pre-appended in the body in the preprocessor?
Well, we're just going to compile the entire body before we pass it to the fold as the base case.
Wait. You were saying that you're gonna compile the entire body again. Ah, no, I see what you're saying. We need to do the calls fresh first to add the lambdas, and then in the body of the innermost lambda of the call with fresh, there we put the compilation of the body.
Yes, and I'm assuming this is going to be a fold. Well, I'm assuming this is going to be. I guess it doesn't matter if it's a fold right or fold left,
Well,
but
you can't
basic,
choose because sets the the, the bet set people.
the
Uh,
point is we're going to take the accumulator, which is the existing expression, and just wrap it in a larger expression that has a call with fresh, right?
yes.
So the initial accumulator can just be that innermost expression that's the body of the thing.
Yes. Um, okay, I think I understand what you're saying. So these XPR, which is the accumulator, is gonna be the body, the initial accumulator actually.
I think that's backwards, no?
No.
Look at the type of the fold.
Oh, it is. There.
Yeah, the initial XPR that we're going to pass as the base case is going to be the innermost body. That's the
Which
actual,
is actually the body of the
which is actually the body of the
this.
predicate. Yeah.
Okay, so that means we do. Wait, what is this thing again? Oh, vars. And now we need to compile this body somehow. This already needs to be an expression somehow. I don't know how we're gonna do that, but
This needs to be a conjunction because it's an and, right?
let's actually do that right now. So this is gonna be inner body. Let's call it like that. Actually, I can call this body. So this is gonna be uh, you said it yourself. It's gonna be not builder beam cutting. Why there's only EQ here? What? Why there's only EQ here? What the fuck? Didn't save the file? No, I did save the file. Let's assume the LSP is just going nuts. So this is a conjunction. And we need to receive it as a conjunction and expression list.
Yeah, we need to
Um,
map over the body of the content.body using.
content body. This returns to us this.
And this is a list of functors, which is going to be just a sequence of function calls, essentially, right?
Sure. So what you're saying, man, we're gonna need another function in this thing. Okay. Make function. This needs to receive a func. A func is a nameF, elements, and an arity. So what are we gonna do to? There is a beam builder function something, right? But I believe that's not
Um,
it. It must be XPR. Um, and then we need to put a function call, right?
and we have call with module. We have call with module. Don't we have normal calls without a module?
I'm gonna steal this list map. There we go. But instead of find variables, is make function. And there must be a to do. Yeah, there must be a to do in here. We should not strip the locations. We are right now due to lack of locations on the in the beam helpers. Okay, did you discover,
Uh,
Marin, what needs to be there?
yeah, you need to add this line to the builder, basically. OCaml.
What the fuck is the parens list separated by semicolons? I have no idea what you're saying. Oh, This is actually pretty close to call with module. Shouldn't we use call with module instead?
The
Because
problem
the
with
EQ
call
is
with
in Karuta.
EQ is in Karuta, but the local predicates that are defined in the source code won't be.
But then we have a problem because we have EQs in the body that are Karuta EQs.
Well, we can assume that every EQ in the body is going to be a Karuta EQ for now, until we implement a proper module system.
Okay. Wait, but that means that we need to inspect the name F.
Well, yes, and we are probably we're probably gonna have to do that regardless in order to implement the primitives, right? Like
Yes.
plus.
That's gonna be annoying. Okay, but I'm not gonna care for that right now. So this is like EQ. This is not how you do that. This is how you do that.
Yeah.
Then we need to do something special in that case, but else we need to do this thing call.
Well, the name F can just be an atom.
Wait, the name F can just be an atom, you said.
Yeah, we can just turn it into an atom, basically.
Yeah, but we need to pass an F and a bunch of args. What is F in this case?
It's an expression.
Is an expression. So in this case, it's beam builder atom.
Name F.
Name F. Man, it's really annoying that we have to do beam builder. We should do open beam here. For whatever reason we didn't. But okay, we can fix that later. That's not a problem. Then, that's the F, and now we need the args. The args
Are the elements,
are
but
the
we need
elements.
to turn them into expressions.
And how are we gonna do that?
Uh,
How are we gonna do that? So, before that, this is beam, Karin, EQ, and same problem. Exactly the same
well,
problem.
in this case, the elements must be a list of length 2, actually.
No, you actually are right. So this needs to be and arity
Arity equals 2.
true. Yeah, but it's the same problem. We need to convert the elements to expressions. Well, to beam expressions, because we also have our own expressions. God damn it.
Yes, we do.
So how are we going to do that?
Let's see. Right now we have functors, we have variables, and we have integers, right?
Yeah, let's actually make that function here. Let probably rec, because the functors are nested, compile xpr. So you receive an xpr, which is this. Right now, yeah, I'm gonna keep it like this. I'm gonna strip the location here because later we can just change this function to handle the location. And
Yeah.
this needs to return beam builder xprt. Then we do a match on it, stripping the location for now. And then we're gonna have a variable, right? We're gonna have a functor. I should also probably do let open ast in. We have a func. We also have, I believe, an integer. Is that right?
Yes, should be.
Integer. And then we have an integer, which we can immediately already do something about it. So this is a number. This should probably return a beam builder
Builder int. I'm pretty sure
lit.
there's an int.
Oh, there is
Oh,
an
there's a
int?
lit. Oh no, it's lit.
Oh, there is an
You
int.
were. Oh, there is an int. Okay.
Okay, now the other ones. So a variable should become a variable, right?
There is a builder var,
But what does it take?
a string.
A string. So this is name v. And then now the functor. This should return a function.
No, this should
A function
return
call.
either. No. This should return either an atom or a tuple.
Well, I guess it depends on the arity then.
Yeah, if the arity is 0, we can immediately just return an atom.
Okay, so let's pattern match the f and the arity. Let's put a when arity equals 0, and let's just say that this is a beam builder atom name f. If it's not that, then what do we do?
We need to make a tuple. I'm pretty sure we have a tuple.
Builder the tuple. Yes.
Then we need to make it takes a list as an
Wait a moment.
argument.
Before we continue, why does the functor not generate a function call?
Because this is an expression.
What would the functor become in Erlang?
A tuple or an atom.
Actually, that makes perfect sense. I'm stupid. Well, I'm also already tired, but that's okay. Okay, a tuple, and what do we do? The tuple takes a list, though.
Yes, so we need to do two things. We need to add the name to the front of the list, and we need to convert the name and the elements into expressions.
Builder. Man, fuck. I can't. Open beam builder in. Actually, just beam. Then we do
Boulder.
builder, builder, atom, name f. What is, continue saying what you're saying?
Now we need to return a beam builder, well, just a builder.tuple. The arguments to that function is a list. So we need to do name cons, and then we need to map compile expression over the elements. So except, does that work? I think we have a type mismatch here, don't we?
There. What? What does this take? An int. What do I have? An int. What? I am confused. What the heck? Oh, this doesn't return an expression. These returns a primitive's literal.
Oh,
So
we
I
need
guess
to
this
add
is
an
wrong.
expert. We need to add an expert.literal in front of that, yeah.
Okay, but
Yeah,
we have
no,
to
no
discover what
attach,
that
just
takes.
no attach, just parentheses lemos, because that's not a function, remember?
Okay, there we go. There it is. We don't need
Try
the
to do
arity here.
try to do a dune build just to check if everything is still okay. Oh yeah, that's right. We need to implement that.
Cool. So this is right now. No, this is still not right. Oh, no, it is. Okay, now going back to this problem. It's the same thing. So now, this is equality on the functor. If it's EQ, what is the left-hand side?
The first of the elements, element at index 0.
Sure. So that means
Compile
that you should do a
expression.
let here, actually. XPRs, and then we do list map compile XPR on elements in, and then we do. Actually, I'm gonna already do the there, and this is this and this, I guess.
No, it's actually the first two elements. The list should have the elements should have length 2 because it should match the arity, right?
Ah, okay. So you're saying that this is this. Oops. This is this. This is this, and this is, should be unreachable, given this if. And then we
Yeah.
do that and that. But this is non-exhaustive now. This is not exhaustive. Sure. So actually grab this and put match with this, that, else, a logger simply unreachable. Um,
Well, for us to reach this case, there should have been a bug in the preprocessor, probably.
yeah, but how do we inform this to the future selves? That's the question. Mm, compilation of primitive built-in EQ is wrong. I'm gonna keep it as that for now. Do we benefit of having location in this case?
Do we?
Yeah, because you're doing, well, this is already generated crap, right? Well, not necessarily. Maybe the user is also doing an EQ.
Yes.
But what if it's one of ours EQ?
Well, in that case, we will get the source location from the argument that uses an
Yeah.
expression to do the
Is
equality, which
that
is the right
good to
place.
be logged? Or should we just not have a location at all?
It shouldn't be. Well, I'm not sure actually.
Because you're going to be pointing at a particular argument of a random predicate saying that the compilation of built-in EQ is wrong.
We should probably change that message actually. We should say, I don't know, mismatch between arity and length of elements or something like that.
No, but that's the thing. We don't know which EQ is this because it's in the same body. If it's our EQ, then it's your error message. If it's the user calling EQ, then this makes sense. We don't know how. We don't have a way to differentiate artificial EQs from like programmer EQs.
No. That's still a compiler bug if it happens, Lemos, because for us to hit this case, it must be the case that the user wrote EQ with 2 arguments, and somehow the list of arguments actually
No,
is
yeah, you're right.
shorter
Yeah,
than that.
you're definitely right. So what do you say? Mismatch
Between arity and length of elements.
like that. Then it makes sense to have location though. But I already stripped them. Fuck me. I already stripped the locations. Yeah. I should not strip them. Yeah, I should not strip them. In that case, we can just get rid of that and just do it like this, which means that now this is content equals, and now we have a location. We
Okay.
do in fact have a location. So this is gonna be what? Didn't mean contents. No, it didn't mean contents. So I am confused. This is body. Yeah, let's actually let open location in. Thank you very much. This cannot be simply then, and then the location comes first. There we go. Don't you love the logger, Marinho?
It's nice.
Cool. So now for the else case. The else case means that this is not EQ. The else case means that this is not EQ.
Which means we need to compile a function call.
Yeah. So we are missing probably the second argument, which is a list of expressions. In that case, we're just gonna do exactly the same thing. So grab this. I should probably put this as that in. And then we can just say xprs, and then here xprs. There we go.
You should rename that to args actually,
Args.
because that's what they are. They are the arguments to the call.
No. Those are the expression, the compile. This is the result of compiling the body. In this case, they are args, but
No.
I'm using the same binding in two places.
In this case, they are args. No, they are the arguments of the call that we are compiling.
Ah, I know what you mean. You're saying, okay, no, I agree now. These are also args for the EQ. Okay, never mind. Okay, so now we have a body. We put it in here. Wait. We have a body, we put it in here. This is a let that has an inner function. Then on the compile body, we do list map make function. Make function gives us form XPR. What does conjunction expects? A list
A
of
list.
of expressions. We have only a single one.
Yeah, we need to map over
This thing.
the.
Yeah, this is already
We
there.
need.
So this is just this, like so. It should be.
Mm,
And then there should be an in here. Yes. So this type is there. We have conjunction of a bunch of expressions, Marinho. And that
okay,
means that
so
I can already also remove that because you're not stripping the locations.
so now we need to fold over that body,
Wait a moment.
adding the calls refresh for
I
the
need to
for the
to do is
variables.
needs to be moved here. We should use locations beam. They don't use locations yet. Being sent as arguments. Repeat what you said, please.
Now we need to fold over the
Using the
set of
body as
variables,
the initial thing.
using the body as the initial thing, and basically we need to wrap the body with calls refresh for each variable.
Okay, so wrap it. So let's wrap it. So beam builder, not builder actually. You cutting.
I
Call with fresh. These expects. I need to create a func now.
You need to create a func, yes.
So, oh man, where am I doing the open? Oh, I never did the open in this function. Let's actually do the open then. Let open beam in. We're not using location in here. I don't know why, but we're not using the location there. I actually should do this. Yeah. Calls refresh. That beam. Well, not beam exactly. I should be able to remove all the beams from the code now, right?
We should, and I just noticed we also don't have a function helper. Let me
We
fix
should.
that real quick. Let function.
This will be what? This will be builder because it's a helper. This would be a function declaration helper.
No, actually, this would be a lambda, in fact.
Oh, we don't have. Yeah, we don't have the lambda.
Clause list. Okay. Lambda clauses equals function. Actually, expert dot fun dot. Do we have a helper for clauses? We don't. Okay. Although in this case, all of them will just have a single clause, no? So in fact, we just need arg body This is a lambda.
We are close to finish. Actually, we're kind of close if you think about it. All of this is to compile declaration bodies. We still have to tackle, yeah, this, but that should be pretty easy after we have compile single declaration. Well, compile declaration bodies, I should say.
Body. Then body is a list of expressions. Are
Actually,
we
we
ever
don't
going
need
to?
this. Yeah. What's the question?
Yeah, I don't think we need more than one body here.
Oh, we still have to change this because we need to do the disjunction. Yeah. Okay, so it's a little bit still further away, but we are very close.
And then for the patterns, we need, what do we need? We need a variable. Um, okay, there we go. OCaml.
Oh,
Yeah,
I'm gonna go
add
to
this to the builder, and we should be good to go.
builder lambdas. Okay, so we need an argona body. We need an argona body. So let's see. Lambda. What's gonna be the argument of this lambda? It's gonna be the var. And what's gonna be the order, the expression, maybe?
It's gonna be the expression, yeah.
This is calling for the cursed compose. Do you know what I mean?
The cursed compose.
The one that we used in the WAM version. Don't you recognize this pattern?
Oh yeah, yeah, I do.
Let's see if this compiles though. This expression has type form xprt, but an expression is expected to be. Whoa. This is not a
Hmm.
func, apparently, what you did. Probably because. Where is this coming from? Yeah, this is not a. Yeah, we don't need this. Okay. This expression has type var set, but an expression is expected to have string set. That makes perfect sense. What I need to do is to
Is
actually deconstruct this into a name v and use the name v here. Unused rec flag. We don't need this to be recursive anymore. And did I save that? Yeah. And then compile bodies. Doesn't need an integer anymore. Yeah, but this is still wrong. We need to fix this now. This needs to be turned into a fold. Does the order matter? That's the question. The order does matter. So
compile single body.
we need fold left on it with this.
Fold
The
left.
the what's it called? I need to see the example. Dang
No,
it.
we need to map compile single body over the clauses. That gives us a list of conjunctions,
No. Yeah, but we need to do the disjunction now.
which is just a single call. You just wrap the disjunction around the list.
So you were
Go back to
saying
the map and put a disjunction around the thing.
to do clauses list map compile single body, and then OCaml dist Is that what you're saying?
Yes.
Okay, so this doesn't need to have a number there anymore. Am I missing something? Uh, this is returning a form XPR out of a list of declarations. What is the expected type of this thing? What is the return on that? Form XPRT. And the type of this takes... Oh, this is expecting a form.clause.clause list.
Ah, okay. You can just wrap this in a record. This can be the. This can be the.
Record? Yeah, let's
Yeah,
actually go
this.
there. I need to check what this is. So function declaration. How do I make... Oh, okay, there's my answer. I need a name, an arity, and clauses. And the clauses is a list of clauses. This seems wrong.
It isn't. It seems wrong, but it isn't actually.
Okay, how is this not wrong?
Because each clause corresponds to a declaration of that function, right? In like when you
Ah,
have
but we're not gonna use the patterns anymore, right? We're gonna use
we
the
are we are not using the
disjunction.
patterns and we're not using the guards either. Yeah. We
Okay,
can
so that
probably simplify
means...
quite a bit of these actually.
Yeah, but that means that we can go... we can make the helper already do that for us, right?
We can.
So, uh, let's just put single function declaration. Maybe in the future, for whatever reason, we're gonna need this. So the single doesn't take clauses at all. It takes an expression, and inside here, it's gonna be doing another record,
It's
which
actually
has
needs to
guards
be
equals to empty.
it actually
Uh,
needs to be a list with that record inside of it.
Even better, there. And
And
we make body equals to the XPR, like so.
the patterns is not right though because we need to actually pass it the arguments.
What? What do you mean the arguments?
Because patterns is the list of patterns to match with each argument.
We're not gonna have that, right? Because in our function calls, we only have the dummy names as for the variables.
We need to fill that in, otherwise we're gonna generate something that says it has arity 2 or whatever, but doesn't have any patterns for the arguments, which means the arguments are not even named.
I see what you're saying. Um, in that case, I need to discover what the heck is patterns. So that, that, it's a bunch of variables.
Yeah, we're gonna need basically 3 variables, or whatever, however many variables are implied by the arity.
Um, that's actually pretty interesting. We don't need the arity anymore. We can just say arity equals least
Map.
length of args.
Ah, okay. And
Uh,
then patterns would be list map args, and we need to we need to call variable on it.
yeah, let me change the indentation of this quite a bit because otherwise it's gonna be terrible. So we're gonna have a list of this, and this guy needs to be a
List map
variable. List map
and
makes sense.
list.map.
What would be the types of args? I think should be just be a list of strings, to be honest.
It probably should be, yeah.
Yeah, but
Yeah,
this
get
is
rid of
still
the
wrong.
square brackets. Get rid of the square brackets. And
Variables is
then
to pick
variable
up.
is not a function because for some reason constructors are not functions.
We need a PPX for that.
I'm not sure if that was a joke, but
What?
you do actually, in fact.
Yeah, you do need a PPX to make constructors functions.
Yeah, but I'm not sure if you said that as a joke. But
Oh, no, no, I didn't. I actually researched this. It is actually that.
I
Pattern.
yeah.
Yes. Nice. So then you go compiler and we say single function declaration.
And then
You
inside of variety you pass args, which is the
we don't
elements
have
that you are
args.
ignoring.
Yeah, we don't have args. And we need to map them. Args equals yeah, now we need the thing. Let's extract variable t string. I should say function variable var equals
Uh,
name.
yeah, we're gonna need to refactor the types at some point.
Which types?
All of them.
Oh, which types? There are like quadrillion types here.
All of them.
I don't know what you mean still, but okay. Error. Which types? Please point to them.
Okay, first of all, we need to refine the AST so that when we have a declaration, we know for sure that the arguments are going to be just variables because the preprocessor guarantees that now, right?
Oh, you mean that
Yeah,
the
that
head
constraint
of
is not.
things, yeah, the head of
Yeah,
things are not being represented properly now,
yeah, that constraint is not being encoded in the AST,
and
right?
it should.
We
Yeah, definitely. Uh, oh, off the fucking course. Content equals, and I actually don't care about the location. Actually, I can use the location in this case to better report this. Should I put location in this?
maybe.
Maybe.
Actually, probably not because the source location is not gonna help to find a bug in the preprocessor, is it?
No. Uh, Trying to extract a variable wrongly. I don't know. Now, here, map ast xpr extract variable on the elements in. Is that even worth it? How much better is the syntax compared to creating a lambda? By the way, in BuildScript I guess you can't use as a function also. What do you
The
mean
point, not
how much
the
better
point.
is the syntax compared to creating a lambda,
The
Nathan?
point, Nathan, is that we're being forced to do eta expansions manually, even though the constructor is logically a function. But it can't be used as a function, so we need to wrap it in a lambda.
Oh, he's talking about the PPX. This expression has type that, but an expression is expected to have type that. That is wrong in the builder. What is the type of this? List.
Oh, you need to wrap a list around the body, actually.
There you go.
Because you can have multiple expressions in the body of an
I'm not
Erlang
using the
function.
arity anymore. I should put this here. Where is the Halo soundtrack, Magetta?
give me a sec.
That is loud. Woo! Okay. Have we
And
done
I'm
a thing?
reflecting what I did, and I'm thinking, what was I thinking? Was I thinking of anything at all?
Wait, looking what you presented in the beginning.
No, no, of the. No, no, not that. That may be as well, but I'm talking about the constraint implementation. Like, I did a couple things that I doubt my sanity.
Oh, okay. Well, you are a genius. You don't understand yourself sometimes.
I don't understand myself. I wonder if
Uh,
Marinho does. Do you, Marinho?
I certainly do not understand you, Mageta.
Do you understand? You
Wait a
understand
moment,
yourself?
folks. Are we ready? Can we call? Can we do a program? Am I
We can
dreaming?
we can try.
Well, I
Okay,
hope you can, because I will be happy if you can.
okay, but let's go to main and see what the. Oh, that's not gonna work. There is a to do. Even there is a to do for it.
Have you noticed
We're
that we destroy our own fun?
I mean, we're kind of already handling the linking in the code. We still need to fix the distribution of the runtime, right?
I don't know what you're calling distribution. What I meant by this to do, I think you wrote it and I asked you to do it. We need to change this guy.
Why?
Because somewhere in here we need to specify that we need to pass as an argument to Earl the Karuta,
Do we?
the Karuta dot Earl.
Do
We
we?
do, yeah, we do.
Do we?
Yes, we do.
Do we really?
Actually, this is also wrong, right? Because this is still doing hello world. Let's nuke that. And what we're gonna be doing is this to do is gone. Assuming all the serialization is also gone, which it may not be. Um, which may not be. And then here we need to
Compile.
serialize the stuff. Yeah, because we have a list. We're gonna have a list of forms. We need to serialize the list of forms in here. What is this taking?
Yeah, I bet. I don't think that's correct anymore.
Okay, there is an attribute thing here. There we go. There we go. So for some reason this is called an attribute. For some reason this is called an attribute. Man, all of these things should not be here. I need to
We
fix the
probably.
fucking compilation errors. So this is builder. I actually probably should do open builder here. But that's still fucked up. So,
Module clause, maybe?
but there's no module clause in here anymore.
No, no, add it.
What? What do you mean?
Clauses from the being built-ins. You need to do the thing that you did for expert as well, for clause.
I'm confused. I'm already
Line
tired. Could
line
you help me?
line 4, Lemos. Line 4. You need to do
For
that for
oh,
clause.
this thing. But that's not gonna. I don't think that's gonna. Yeah, that's not gonna
No,
fix
no,
our
no,
stuff.
no. You have to do it inside of builder, Lemos.
I have to do it
Like,
instead of builder.
yeah, copy this line, replace the experts with clause in the copy.
Ah, you mean this? But I
Yeah,
need to
but this
also
needs
do
to
the
be
open.
no. This needs to be this line that you added to the serializer needs to be in builder.
Ah, so you mean this should be here,
Yeah,
and then here I
you can
should
get
not
rid of those
have to
two.
do those things. Didn't fix it. But maybe that's because, yeah. So there is a pattern in line
Do the same,
25.
yeah, just do the same thing again inside of builder, just with pattern now. And for primitives as well.
That's very dumb, isn't it? But the re-exports are not imported for whatever reason. Module form.
Module form, I'm pretty sure that comes from. Actually, where does that come from? I forget.
There we go. Module form. Probably inside core. Module form. Yep. Ah man, you know what? I'm just gonna. Ah. Yeah, we need to discover where it comes from. It comes from clause. So can I just do clause here and call it a day?
Actually, no, that's not from clause.
It is. It's saying here. Module clause, blah 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 blah. Vol module form.
Module type form, module form.
I think you were exploiting something that comes
No, no,
from
no, no, no,
this
no, no,
thing.
no. It's not from there, Lemus. That module form comes from a module called form, actually.
Oh, so we need this as well. That's what you're saying.
Which is. So we're already opening it, so why is it not there?
No, we are not opening it.
We are.
We are not. These should fix it.
I can delete booleans.
Nice.
No CMI was found from module primitives. That is very weird. So if I remove that, will this compile? No. Okay, now I am a little bit... Oh, maybe I do need this guy for whatever reason. Oh, I do. Okay. So there should be a single error, yeah, down here. Compiler now is fucked up. Awesome. So now let's go to compiler. Where are you fucked up? Line 42. 42. This thing. What is the type of forms? It's a finger tree. That's a finger tree. Interesting. Why is this in the serializer? Yeah, that doesn't make sense. Why is
Well,
this there?
well, because you've just moved it there.
These four things should not be here, man. That's the problem. I don't know where they should be. We probably should also have a module attribute in here then. Sure. Attribute. I already forgot the syntax because of course. And there. So there we go. Those are not stringifying things. So they should not be that. There.
Why not?
What do you mean? String of var. These are all stringifying everything. Stringifying. Yeah. I think this should be okay, which means that I should go back here and undo these things. And let's see. Yep, that worked. Now we go to Earl. I can remove, theoretically, I should be able to remove these, and I should just be able to say, hey, serialize my forms, please. Okay. Now main is fucked up. 25. So this is doing nothing. Oh, of course. No. Executor.form.t. What the fuck is an executor.form.t? Oh, this. Okay, that's fair enough. What's the problem? This expression has type ast.clauseList, but an expression is expected of type executor.form.that. So I guess that means that we must compile. What is wrong? Oh, I must initialize the compiler. That's very fair enough. What is this returning to me? Executor.compile. Ah. Okay, this is wrong. I should change the... I need to change these two forms. We're not gonna print them. And this is forms. And then in the executor, whatever we are doing with compile, let compile, this is just preprocessing it, which means that it is time to actually introduce the compiler here.
Yep.
Which means that I should uncomment functions. Initialize with the file name. What else are we passing to the let initialize? Just the file name. We have that. We actually have that. And compile takes, yeah. So what is this returning? This is returning an attempt. So this needs probably should be, ooh. This doesn't fail though. Is that? Or do I need to do it something like this? But this is not monadic. This is not monadic. Which means... Okay, how would you approach this, Marin? Would you make this monadic to make a type check, or you would hand like just change this thing here to not necessarily return an attempt? Tough choice. Okay, just to make this easier, I'm gonna actually put this returning an attempt. So that means that this exit will not happen anymore. Well, actually, we can keep it this way and just put an OK here. So now this is a monadic function, which means that this is also a monadic function, which means that
You have two functions with the same name, Lemus.
I do. That's true. Just fix the type first. One moment. This is now the correct return. And now I need to rename. Okay, so how much do I want to piss off the ML people? If I want to piss off them very high, I'm going to do this. And then you just do it like that.
We're talking exclusively about OCaml people.
Can't you just get rid of that function, Lemus? Just call compiler initialize, put that in the pipeline, and then pass it to compile prime.
Sure. Like that. What is the problem? Unbound var unbound. Oh,
Oh, that's called file path for some reason.
which is still wrong for some reason. How is that wrong? What is the return of this? Ah, this returns a clause, which means. I see. Okay, just to gain time, I'm gonna nuke this, which means removing preprocessing. I'm gonna assume you're always gonna call this compile, which will always preprocess for you.
Okay.
That's what I'm gonna be assuming. Yeah. Is there no problem by doing that? Is there no problem? Wait, but this is wrong, man. Because I don't have a compiler in this moment. I don't have a compiler. Oh, it's here, my bad. So that means, okay, compiler, compile, decals queries, comma, compiler. This expression has type executor form t bet finger tree, but we were expecting a list.
Mm,
Okay, now the choice is we rather change this function to use finger trees or we transform this to a list.
executor compile is the one that you just wrote, right?
Yeah.
Earl compile expects a list, right?
Yes, we can either change the signature of this or change the type of this to be a list.
Go into Earl.compile, please. I want to take a look at it real quick.
Right there.
We're just using map and then passing that to string concat.
I think we can transform this to be also using finger trees.
Yeah, we can.
It's just bet finger tree. Oh, there isn't a map.
No, there is. The problem is that
The forms are not.
string.concat expects a list.
Ooh. Now what?
Can we convert the forms to a list then? That's probably, it's not ideal, but it's the easiest way to do it.
But you want to convert it in here and keep in the main.ml, you want to keep the finger tree.
In the main.ml. We can probably convert it there actually, that's probably easier.
Okay, so let's go back to list. Bet finger tree to list. Fuck that. Emacs. There. I am nervous. I am very nervous right now.
It will work, Lums. Don't worry.
So we have a full blown. Oh, we don't have queries.
Actually, we don't have queries, so we actually can't see what we're doing. Yeah.
Why do
No,
we
no, no. We
always
we can
neglect
we can
printing,
right.
querying?
We can see the. But that would require.
Can't we decompile the bin file?
But we don't need to do that. We can print the forms. And then
Okay.
we can print the forms, grab it, go to a repo and run it.
Okay.
So that means that this should have a print Inline
That's what I'm
forms.
saying. Why do we always neglect the most ergonomic things to do in a language?
I
Have you
don't.
thought
What do
about
you
that?
mean?
Like printing.
We neglect printing?
Well, we didn't have printing on the previous iteration.
No, because in the previous iteration, having side effects is harder than doing simple arithmetics.
Well, I'm not questioning if it's hard or not. I know it is, but we clearly neglected it. That's still my point.
No, it's because when we actually started doing cool things, we decided to drop the VM. So, uh, okay. Anyway, so now what do? We we do what I said. We do dune exec karuta compile, and we need a test program. I want a very dumb program. What is the dumbest possible program that could be written in a logical language?
Equals AA.
Equals is forbidden because it uses it's a built-in.
Why is it forbidden?
Because if you write equals right now as a separate declaration definition, we are not going to use your equals. We're going to use our equals.
Oh, that's true.
Then just make like potato 1 1.
Okay, Marinho, do you agree that's the like the lamest and simplest possible program?
Well, the lamest is actually just potato 1, but
Can't you just put this plus there?
we should be able to, yes.
well, that's definitely not the lamest. But feel
I
free.
okay, this this is the simplest possible program.
Not really.
We don't have the integer built-in though. Okay, you know what? Fuck that.
Man, you can put an
Yeah,
atom,
let's just say
literally
this is
a.
it is what it is. Let's just say that.
Yes, literally that's true.
Okay, so this should work, Marinho. Theoretically.
Um,
Well, assuming that the suck is a data structure, right?
it is.
So
Actually, you can just get rid of the int inside of the net. You don't have to get rid of the entire net thing.
No, but that simplifies even further because right now I don't want many moving parts. I just want the simplest possible program. Am I understanding
Okay,
that this is it?
okay, let's give it a shot.
we're not done
Examples
maybe correctly.
Plus,
uh, plus Karuta.
Um, that's
We
not
failed
good.
miserably.
Man, like check the chat. I love that man.
This is not Monad. Yeah, I saw that. Okay, this means that there wasn't an invariant that we assumed that it was wrong, actually. Which is this one. So
X.
apparently there are elements inside the thing, inside the head of the thing, which is even worse. Um, how? What the fuck is the
Mm,
preprocessor doing then? Did I save the preprocessor? I did. Do you agree, Marin, that this must be the case?
yes.
Okay, can we print a functor? We should be able to. So print inline. Let's actually also say func. Is that how that works? Do I need parentheses?
You need parentheses.
Print inline ast show func. That. Let's go. Wait, what? There's still things.
Wait, what do you mean? Elements, location, integer. What's the program again? Can you
This
put it
is
on the
wrong.
slide?
The program is this.
So the first clause is like plus, yeah, 0 out out.
Yeah, this is wrong because at that point of the program, the preprocessor should have already renamed all the variables, but we are using the old things.
I
How?
see. Well,
Do
check
you
where
agree,
you
Marin, that
are.
this must be the case?
Yeah, no, there's something wrong in the preprocessor, definitely.
Okay, so there's something wrong in here. Let's read this more carefully. So you grab the clauses, the parser clauses, you remove the comments, you group them together, you check for empty heads, and then you do the multi-mapper. Where are we doing the function that we just did? Parser to compiler. Parser to compiler. It's inside the multi-mapper. Parser to... There we go. Ah! That only works if it's a singleton. Tururu!
Wait, I have the sound. I hope this doesn't flag the thing.
Well, can't we just call that function in the other case as well?
Why are we not
Oh, but
calling it
then
in the other case? That's the big question.
don't you need to what's the type this function takes? Just an expression?
No, it takes a list of parser clauses and it transforms to a list of
No, I mean
inner.
the parser to compiler.
It takes a
Yeah.
parser clause and returns a list of clauses.
Okay, it just picks one element, right?
I don't understand why we're not doing anything in here. There must be a reason, man.
Just put it inside of the square brackets and call it a day.
Just put it inside the square brackets and call it a day. Where? Which square brackets? This one?
Yeah.
Oh, but
Okay, so you
you
want
do.
parser to
I don't know.
compiler in here.
Inside of the square brackets, Lemos.
Here?
No, that's inside of the curly braces. I said inside of the square brackets.
This is already a clause though, and this takes a parser clause.
Okay. In that case,
We need to map, no?
It is this thing that you want. This is the parser clause.
First decal. Man, I
uh,
have no idea what you guys are doing there.
Okay, let me explain to
no,
Mageta because he's
that's
very confused. We have a function called multi-mapper that takes a list of
Yeah.
parser clauses and gets us a list of inner
Remind
clauses.
me what is a parser clause
A
on
parser
this ASP?
clause is the data structure that the parser spits out.
It can be anything, right? It's like top
Yeah.
level
So
construct.
what is
It's a
the
query,
difference
whatever.
between a parser clause and a clause? A parser clause doesn't have the understanding of groups. So for example, if you have multiple clauses of plus with the same arity but you're
Oh,
doing
got
different
it, got
pattern
it, got it.
matching.
Yes, you need to group them because of the
Yeah.
shared
This is what
semantic
a
code.
multi-declaration is.
And wait,
However,
just one thing. It's by that and arity, right?
yes,
Okay, got it.
we
It's by the
know
name and
they already
arity.
have the same arity because you already grouped them before.
Okay.
Uh, Mani, do you have any idea why we're not calling parser to compiler in here?
we should, I think.
No, we definitely should, but why are we didn't do
Oh,
that
maybe it was
first?
just a Sneakman. Just add it there. Assume it was wrong. Well, it seems wrong, but
Okay, what's your suggestion, Mani? What is...
Uh,
Let me also read this again. Yeah, this is doing... Yeah, this is already doing everything that we need to be done. Right? So if it's a clause, if the clause is a if the clause is a declaration, we just return that. I have no idea. What are we doing, man? What the fuck?
just call the function, Lemos.
Man, am I dreaming? Like, isn't this just like, isn't that it? What are we doing down here?
I have no idea.
Am I crazy, Mani?
No, just call the function lemos.
No. Do you agree this is it?
Yeah, just put that inside of the match.
No, we don't need any of it.
He's like it, yeah.
Like, isn't this the solution to our problem?
From
Ah,
declaration.
this takes a parser to a list, so this needs to be like a concat map of sorts. Isn't that it?
Yeah. It's like it.
Uh,
What is the difference between doing this and the match, Maria?
parser to compiler.
I think we need to read what the fuck multi-mapper is being used for.
Oh, there's
Multi-mapper.
only one difference. Go back there to the clause that you had there.
Oops.
So
Oops.
wait, where?
There.
So look on line 147. So you are doing a nested, right? So in that case, you will not nest, I assume.
Ah, okay, that is the reason why this is not just this. It's because if you have, when you're multi-mapping more than one, we put the first one here,
Oh,
and we
but
put
can't
the
you?
rest of them here. What is this doing? This is assuming that you have a single parser clause, and in that case the body is empty. Yeah, this is the difference.
Ah,
That's the
yeah,
difference.
got it.
Okay. Now I can. Okay, but that was weird. Where do you want to put it, Maria? Where do you want me to put it?
Uh, can't you just replace the group inside of the match with a map parser to compiler group, and then get rid of the redundant call inside of 141?
Okay, so you want me? No, I cannot, because parser to compiler uh, does a single clause. Oh, you want me to map it then?
Oh wait, but if it takes a single clause to a list,
You want me to do this? Oops, group. There. Is that?
multi-mapper. Let me look at that again.
Don't remember anymore, Nathan. This is like has 1.5 years old already of code.
We're doing a concat map on multi-mapper.
Yeah, the group is definitely the group of clauses. So they are the multiple pluses for sure. 100% sure about that. This makes perfect sense. The parser to compiler is putting a multi-declaration with a singleton. So this means that you only have a single case of your group. If your group has multiple clauses, such as plus with 2 or 3 clauses, then we need to do this thing. But here's the catch. We don't need to do... We need to do something here,
Ah,
I think. Yeah, we need to do something there. This makes it a parser clause.
hmm.
Yeah, I see what's going on. This this needs to be classified as, yeah, this needs to be first. So that's the first. Then what we're gonna do, oh, but I do need the location. So this should be called first, but we're not gonna use the content for this guy. Then we do like that. The first, we need to call the thing. So what does this take? This takes a single parser clause. So let's say, um, yeah, this language has shadowing. So first equals parser to compiler on first. This this is not gonna work because it's already returning a clause, right? So I need to pattern match, and it's gonna be yeah, it's gonna be trashy. We need to extract the renaming behavior. Oh, I already have a separate. Okay, so Control Z all that nonsense. Yeah, rename. Thank you very much. And what the fuck is this doing? This is what does this take? It takes declarations. But okay, option number one. We compose the from declaration with the strip location. Option number two, we add the renaming on from. Marin, what do you prefer?
Uh, it's probably better to add the renaming on from, I think.
Okay. Let's rename. There we go. And then this, I can feel this biting us in the ass in the future. There we go. So now, where was I? There we go. Same thing as before, but we rename it here, and the from declaration rename it as well. Okay. Failed to evolve. What the fuck is going on? Okay, so it actually did the renaming the second time, so let's remove the print. So where was I doing that? Um, does anybody remember where I was doing the print? Here. OCaml. We don't need this anymore. Okay, here's what's going. Okay, this is expected actually, because you should not be able to run this as by itself. Wait, this is not gonna. This is failed to evolve. Why this failed to evolve?
Mm,
There is no query on the thing, so you could not load the REPL with that. Is that what that means?
it's because the serialization is wrong.
Ah, okay. Where? Which part of it?
Um,
Which part of it is wrong?
okay, so first of all, the part where we are on making the attribute for the file. See example slash plus dot krt, and then we have
Yeah, this is wrong, right? There's a quotes here and
yeah, the
quotes
quote is
here.
in, yeah, no, the quote is in the wrong place. Quote is in the wrong place.
Okay, so this is in serializer file. Um, the file name already has this, so this is not required. Wait. Oh,
Escape
cat.
string. Escape string. Is that doing something wrong? I think.
Escape string is doing this. To do properly escape it.
Um. Okay, go back down there where it's being used. Attribute one
Why are you
file,
escaping it?
because the file name is an OCaml string. It can have quotes and stuff inside of it, right?
Ah. Oh, but in this case it won't be. This is a file name.
Um.
Like, we should fail miserably, like in many steps before, if you pass anything that is not a proper file name. I should say file path.
We probably don't need the cat, actually, now that I think of it.
So you're proposing
Yeah, get rid of
this.
the .krt as well. Yeah.
What? Folks, this means that it could evolve. Uh, there is a thing. There is a thing that I did. Option dash dash run optional function option function name argument to be called when running the program after compilation.
We should probably add. We should probably actually. We're missing a pass here. We need to collect all of the predicate names and add exports for all of them. We're not doing that.
Does that matter for the test? I don't think it does.
It
That's
does because if you export a predicate, a function, Erlang is not going to consider it unused anymore, and then we can run it on the REPL.
But isn't it easier to just grab this output and go to a repo and try to see what happens?
But we can't do that because the function is not exported, so how are you going to call it?
Ah, fuck. I think you're right. Okay, so wait a moment, let me read this. Optional function name argument to be called when running the program after compilation. Ah, but we don't have, we need to pass arguments. This is assuming like a function that takes no arguments. Because I was assuming that you would pass main to it. But you want to pass something that is not that. Yeah, we need to do it via the repo, unfortunately. Okay, so where do we do that, Marin?
Another day, because it's almost midnight.
Okay, but this is progress, right? Do you agree that this is good news?
I think so, yes.
I'm gonna finish the recording.